Hi everybody, I'm going to show you the inner workings of a Denso gear reduction starter. So this is the gear reduction here. This is the motor portion of the starter. This portion here is the solenoid. Basically you're going to have your key on power going here. This is your main battery. When the solenoid contacts connect, it's going to send power out here to turn the motor, which will pull the drive out, and the drive will go into your flywheel and spin your engine over. So this is a starter that we've taken that we're going to look at tonight. I've taken one apart just to save a little bit of time, but this is the general look of it when it's all together. So this is your basic motor part. Has an armature, field coils here, 4 brush setup, so there's 4 brushes. And this is the power side that comes out of the solenoid. So when you engage the solenoid sends power to this wire through the contacts on the solenoid, which spins the motor. The motor connects into the gear reduction portion. So this spline will hook into this little gear, which will turn this idler gear, which will turn this starter drive. Now this starter drive, the end gear, is hooked to the gear that's going to come out and actually turn the flywheel. Okay, so basically what happens is this is the inner workings of your solenoid first off. So on this side of the solenoid, you see your battery positive. So this will go right from your battery positive to this terminal here. This little terminal, it's a push-on terminal. A lot of times they'll have a stud sticking out that you have to put a nut on. But this is your signal that's coming from your starter. So your starter or your button on your vehicle will send power to the relay, remote relay or remote solenoid, and it'll send power to here. What that does is energizing. Here there's a coil. So this is an insulated coil. Your power will come to here and it will ground out through the motor. So this wire is hooked onto here and the motor will actually complete a ground so that the solenoid will fire. So in this solenoid, you have what's called a plunger. It's a copper contact, and this is the return spring. So this plunger sits in here above the 2 contacts, above your positive contact and the contact that grounds out through the motor. So this cover here will sits on top like that. So when you energize your solenoid, this plunger actually pushes down, and what it does is it connects both of these copper terminals, and it sends your battery power from this terminal through the round disc out this terminal, which spins the motor, which will cause the motor to spin. The motor will spin the planetary gears, and at the same time, this plunger, when it pushes out with the spring, it actually pushes, it has a dual purpose. Not only does it connect the contacts inside the solenoid, but it also pushes this gear out so that it comes out and connects into the flywheel of the engine and turns the engine over. So it does have a couple different jobs to do when it's energized. Just a quick tech tip here. 90% of the time when these starters fail, they're a very good starter, but the weak point is the solenoids. And you can see how much this contact is actually wore. There's a big ridge there. So this ridge should not be here. That's how much it's worn. And also the plunger, you can see the wear mark on this plunger. So when this plunger comes down, it keeps making contact on there, and eventually the high current that goes through there actually burns that out. So what you'll get is you'll get a no start condition where you hit the key, your car clicks and nothing. And if you try it a couple times, usually this plunger, if it's got a bad spot, it'll kind of rotate and bounce around a little bit, and it'll make a connection and your car will start. But inevitably you're on borrowed time. This area here should be just as thick as this. So it's this one is well wore. And like I say, 90% of the time, that's the weak point on these starters. When they come in, it's because there was a solenoid failure. They're very easy on brushes. We hardly ever have to change the brushes on them. Field coils, armatures, they go a long distance on these starters. They're a very reliable starter. There's a couple different versions of the contacts. This one's not so bad, but you can see where it's starting to wear. This is just the other side. And you can see the pit marks, how it deteriorates over time with with the plunger hitting it and arcing out on it. One big thing, if you're ever going to repair your own starter and you change these contacts, this plunger, when it goes in, there is a ball that goes on the end of that. That ball actually, here it is. This ball sits inside the starter drive. And all it does is it allows for the end of this plunger to ride on the ball, so that when it energizes and it pushes down and this starts spinning, the ball has a kind of a concave area to ride on. If the ball was missing, two things would happen. It would burn up this spring, the plunger would fail, and it wouldn't push the drive out as far with that ball missing. So it would work for a short time. It would eventually burn up, and like I say, it would barely make contact with the flywheel because that ball is about a 1/4 inch thick. So it's going to push it out that much more into the flywheel. So basically, when we put this one together, I dropped the ball in there. This one is a new starter that I took apart, so you can see there's grease from the factory. We usually put just a lighter lubricant in there just to help it along. So the bottom of your starter, this would go on like this. And there's 2 bolts that go through here and screw into the bottom of the solenoid. So look, my ball is in there. I made sure of that. Your spring and your plunger go in, and you can see how much that actually moves. So picture if that ball was missing, how much less that would actually go out. And then this is just your cover. It has a gasket just to keep the water and whatnot out. And 3 bolts hold that on. And your armature, as you can see, there's armature has splines on it, and that little gear inside there has splines on it as well. So, and it's marked, it has a tang on it, and that tang goes in this little notch here. So when you drop this in, you got to be careful, because if the armature slides out of the brushes, it's a little bit of a bugger to reload these brushes. So you want to try to make sure it doesn't slide out, just cause you some grief if it does. So that goes in like that, down like that. Have your cap that goes on. through bolts go on. So you tighten everything up. And then one thing I want to point out here, these two bolts here, they thread into the top of the brush holder. That is your ground for the starter. So if these bolts are loose or missing, or they get corroded over time, you could lose your ground on the starter from the brush holder to the cap. And that is a very important thing. So if you're gonna, again, if you're gonna work on them yourself, just make sure everything there is nice and clean. Obviously this is a new unit I'm using for demonstration purposes, but you always got to make sure your surfaces are clean so that you can have a good ground. And then this connects to the opposite side, just with a nut. And then this boot just covers up because you don't want that to hit anything. So just to go over briefly, this is your main battery. This is your signal wire from the ignition switch or button. Probably runs through a relay. So when you hit your button or your key switch, you trigger a relay or a solenoid that sends power down to this. When that happens, the plunger comes down. Okay, so you got your plunger. It's going to come down. It's going to connect to both of these, and it's going to send main battery power through this terminal, through this copper ring, which is insulated. It's insulated from the holder, out the other side, through this wire to the two positive brushes of the motor. The motor has two positive and two negative brushes, and then the negative brushes are welded to the brush holder, and they get their ground through these two bolts here. So that basically the workings of it. And once again, I just want to remind you, this has two purposes. When it comes down, it not only connects these two contacts to send power through the starter, but it also pulls out the starter drive. So it'll pull the starter drive out, and it'll hold it out until you let go of the key, and then there's a big spring in there, and it'll spring it back in so it disengages from the flywheel. So once again, they're very versatile starter. They fit. Denso has done a good job with them. It fits a lot of different pieces of equipment and vehicles. Very widely used. They come in different shapes and sizes. This one here, this is a bigger one off of like a diesel engine, a Cummins diesel to be exact. This one here, you can count 2, 4, 6, 8, 10, 11 tooth. This one is 13 tooth. You can see the size of them are different, are way different, but again, the inner workings, they all work the same inside. Again, this one here, that's your signal from the starter. That's your main battery. Power would travel through. The plunger in there is way bigger than this one. The contacts are way bigger. That plunger is going to come down, connect these two, sending power out to the motor. The big plunger in there is going to pull the drive out as well and engage it with the flywheel. So that's about all I got for the Denso starters. If you want to send me off any questions, if you have any, and thanks for watching. And there's a lot more videos to come on different styles of starters and their inner workings. Thanks very much.